Video is not working.
Soumya, you can start. Soumya. Okay, sir, he's already our research person, Dr. Sarath Kumar Das, sir, has already joined. He is the professor from IIT Dhanbad. And his topic. Now, sir, I request to sir kindly present your PPT.
Okay, thank you. So let me allow to share my screen. I mean that.
Sir, you are not audible.
Am I not audible? Hello.
Yes, sir. You are audible. You are audible, sir.
Audible?
Yes, sir. You are clearly audible.
Okay.
Not audible.
Okay, let me share my screen. Entire screen. Is it visible now? Hello?
Yes, sir. It is visible. Yes, sir. It is visible, sir.
Okay. Good evening, everybody. Sorry for the delay because I had some issue with this Microsoft. So this I'll start with this one, what we call it as geotechnical. Just a minute. Just a minute, sorry. कट गया क्या? Two files are open. Just give me a minute. Okay. So now is it visible? Hello?
Yes, sir. It is visible, sir.
Okay. Just a minute. So thank you, Dr. Meena, for giving this opportunity. So I'm really sorry to start it late due to some problem. So I'll discuss about this mining industrial waste as a construction material with sustainable assessment. So first I'll come waste. I don't say anything as waste. I say because we don't have knowledge, so that's why we are saying it as waste. We have got limited knowledge about it. If we will get partial information, we say product. Where we have got full knowledge, we got it as resources. So just imagine few hundred years before, when we were not knowing anything other than iron. So that time we had no other minerals were also waste. So now when we got the full knowledge about it, now it becomes resources, what we are calling that ore or minerals. So this is the first principle of waste to wealth. It is only the knowledge. So once we develop the knowledge, it becomes wealth. Another one, sustainable development goals. Nowadays, hope most of you know about these sustainable goals. There are altogether 17 sustainable goals in these three domains. So when I'm talking about these three domains, so we are talking about this economy, society, and biosphere, or we talk in terms of people, profit, and planet. The sustainability word was there, but initially they were thinking about only the planet. That is what we call environmental. This will happen, that will happen, and so on. Then over the years in 80s, people added to that how it is going to people, how it is affecting the society. Later on only in 90s, this profit was added, that economic part was added. So these sustainable consist of three parts: economy, society, and environment, or it will say people, profit, and planet. So accordingly, if you will say, I have also divided, if you will say people, so it is no property, peace, justice, all these are under society or people aspects. When you're talking about economy also, you can see different aspects. So accordingly, I've given the color. So these you have to understand that, and finally 17 is the collaboration. All these three are collaborated, which is called as a 17 core. Otherwise, all 16s are here, either is related to profit, people, or planet. One more aspect. I will tell about here material, sustainable material. What we need. So if you see right hand side, it is showing a river bank and people are digging sand from other side. Here I am showing also a river bank where there is hardly any water, mostly they are taking the sand. This is a common scene, and if you see the sand is mostly what you say, hardly we have understand its importance. But look at this diagram. Till 2011, which is the maximum consumption, sand, gravel, and rock. Metal you see less. This green part is up to 2011. Coal, limestone, wood, crude oil, cell, fruits. All these are less than. Hello, hello. Okay. So all these are very less in compared to the requirement or being used up to 2011, the sand, gravel, and crushed rock. And now it is projection up to 2060. There also maximum utilization will be the sand, gravel, and crushed rock. So imagine what is the requirement of this material, which is simply we are saying a fine aggregate or coarse aggregate. How I am getting it? So as far as you are understand, very easy. River sand mining. Mostly we have heard about sand, river sand. But now slowly metros are going for hard rock crossing, that is Chennai, Delhi. Now river sand is banned, so we are getting hard rock. Another in some part, people are also, they are just think about Evelyn deposit, that is your desert. There they can get surface sand mining. So these are three types of, this is what we call as a lithosphere. Because our earth, lithosphere, biosphere, and hydrosphere. So in this lithosphere, this is what you are getting it, processing it, and then making it as construction. Now, what we want to add one more, it is industrial waste. So it will be added to these resources. Then we'll go for construction. Again, this construction and demolition waste will go back to process it and get back again for the construction. So this is a very big market. And just imagine, India is digging 500 million metric tons of every year. And industry is $50 billion. Just imagine 50 billion, 5,000 crores dollar. If I say 5,000 into 80, $4 lakh is the sand, aggregate sand. Then what is the problem with this industrial waste? Why you are saying it is a waste? Because it contains some heavy metals, it may be acidic, and so on. Mostly it is the chemistry or heavy metal which is creating problem. What are the heavy metals? heavy metals are copper, zinc, lead, but just imagine their rate. Chromium may be 10 times costlier than the iron. And chromium is difficult, and chromium will not allow. But then if you can extract it, do to some, whatever you do, if you can extract it and put it in the recycle other industry, you can make battery, you can make it other things. So then my aggregate become clean, no heavy metal. This heavy metal is extracted also utilized. This is what we call it as a circular economy. Most of you have heard about this circular economy. So why I am saying, so now come to first a technical sustainable part, I have to see the chemistry. So see, here I am talking about coal mine overburden or general soil has got very green. All that is material therein has no hazardous effect and it is as good as utilized for any purpose. Whereas if you go to suppose a ferrochrome slag, you see chromite is 2 to 19%. Magnesium is 5.7 to 35%. Similarly, all these other industrial waste who are getting it, they have got some very different. Some are very high pH. Here you see 4 to 9. This is our soil pH is very good. But here you see starting from 10 to 12%. All these chemical compositions has made it because we don't have sufficient knowledge how to use it. So that's why they have become as waste. Whenever you feel like, you can ask me question also. So these are the different way we define. One is the fly ash. If you see, it is called CL. That means mostly acidic type. If you come to this one, calcialic or so this is alkali. And here in this low acidic, so in this range, it will be there. Similarly, if you have got carboxylates, that aluminum industries, so there you will see mostly iron compound is biased compared to other. In GDBS also, we have got both calcium and silicate, and when I have got using it, I have to find out different parameters. So these are the parameters you should utilize if you want to assess for what purpose you are going to use this GDBS. And one more thing always I tell you, don't get confused with the chemistry and minerals. They are mineralogy, they are different. Mineralogy is a crystal form. So chemistry may be same, but if the crystal is different, they're different minerals. So for that reason, when you are getting any waste, you just also not only get the chemistry, but also find out minerals. So through these minerals, you'll be able to guess. Now, when I'm going to use it as a sand, if I'll go for Indian standard sand, it is quartz, and quartz. But any other industrial waste I'm going for, suppose it's a ferrochrome slag,
Sir, your mic is muted, sir. Sir, unmute please.
Sir, voice is not properly audible.
Okay, no, let's start. Language.
Sir, you are muted. Unmute yourself, sir, please.
Hello.
am I now audible?
Ah, yes, sir.
Hello.
You are audible.
Okay. So this, I don't know what is happening today. So you see, as I said you, there is a difference between the chemistry and this mineralogy. When I'm talking about this chemistry and mineralogy, you have to be very careful. And what I showed here, the river sand, what you are using, or the Indian river or Indian standard sand from Tamil Nadu, which is also a marine sand, or that river sand we can say. So they are containing only quartz and quartz. But in other industrial waste contain all different things along with the quartz. So that's why we need to read it carefully before utilizing it. So are you able to see my slide also? Hello?
Yes, sir.
Yes, sir. Slide.
Okay. So because of what I am facing the difficulty in between, you can also remind me if I am somewhere problem. So next, what I am saying about this shape, size and shape. So we say 75 micron, or even I will say also, this is, don't read this one, this is actually 200 size, not that mm. So from suppose say that is 75 micron size here. So these along with we call it as a sand or a coarse grained material. So right side also, that's why I have shown you here. This one you will see from different particle size, a model showing from steel, sand, and so on with a gravel folder. The thing is that how they are generated. If you see all the coarse grained, they are mechanogenesis, mostly mechanical. But like Indian standard sand, what has happened? Gravel has broken to make this sand. But now think about these GVAs. Particle size is looking at same, or this red sand from bauxite residue. Particle size are looking like same. But it is mostly by crossing. But again also might be gone through this thermal. So these aspects also make a change, which why we cannot directly say these are the same as that standard sand or natural sand. Similarly, fine grained soil. If you see thermal based, you might have heard about volcanic gas. Volcanic gas are very good pozzolan. Now think about your fly ash. Same thing. There it was naturally after high temperature, they were getting cooled. Here it is in our power plant, we are 1400 degrees centigrade and suddenly we are making it cool. So they have got similarity. That's why immediately fly ash become a pozzolana, and for last so many years we are using pozzolanic cement. So similarly, when we are going for industrial waste, we have to see in nature what is its similarity, and what I will try to do, I will try to use it in the similar way for which I am using since these days. So this is again further I have said you, these are the suppose standard sand, and this is you see from red mud. I have calculated bauxite residue. See how able to know they are different. Almost they are looking same from the shape. So though in ferrochrome slag we have got different varieties. Some are white, some which are red, sorry, dark, that means alkali metal, heavy metals, and somewhere maybe something like this, uh, uh, I mean stick-like things. So this type of morphology needs to be studied for using it as an aggregate. That is what important is. Now, now I am coming to triple bottom line. I have told you first that some of the materials, how it is, we have to go for it. What is this triple bottom line? As I have told you, people, profit, and planet. So in the environmental part, which we calculate for the sustainability, we call it as a life cycle assessment. So when you are going for sustainability, you should understand what is this life cycle assessment analysis is. So it has got two parts. Here I have said you that if you see, when I am going for life cycle analysis, I have to fill a boundary. What I want to go for, like I have to fix a goal and scope. Whether I'll go with product or I'll go with the only process, and or I am taking only some aspect of it. That boundary to fix. Next, what are the inventory I am going for? I am considering only the material part, or I am considering everything, like only raw material or for its product. If I am going product, I have to take about fuel, heat, electricity, all this. Then when I am going for its impact, whether it is short impact or long-term impact. Suppose Global warming potential is GWP. So one example I said. So these life cycle assessment you have to be very particular about what you are going for, and that's why you have to follow. We don't have any Indian standard. You have to follow ISO, that is International Standard Organization 14040. And one more aspect I am telling you here, that is called one midpoint indicator, other is called damage indicator. Midpointer is, if you are going for, it is only small one aspect of it. When I'm going for damage indicator, it is in a bigger aspect of it. So if I am only for air pollution, it is midpoint. But if I am I'm going for only global warming potential or smog, that is midpoint. But if I am saying air pollution, it is a bigger one, damage indicator. So this way, there you have got a characterization factor. We can go this way, that how much is the fate, how much is the emission, divided by this exposure, how many hours you are exposed, then effect for each exposure. All these things we calculate. Finally, it is called effect by emission. This you need to calculate, and that CF we have to multiply to find out the midpoint indicator. I'll come in detail. This what I am saying, that you should know what is life cycle assessment. Here I have given the example, some midpoint, some endpoint. So some are like, when I'm talking about human health and something well called ecosystem, and here it is something about only climate change, only one part is global warming. And when I'm talking about resources, whether it is a mineral extraction or non-renewable energy. So this part is there in your, when you go for life cycle assessment, you have to identify these things. Then there are certain uncertainties in life cycle assessment. So these aspect, once you have understood what is life cycle assessment, you have read that ISO 14046, then you can think about what are the uncertainties still there in your analysis. There could be different types of uncertainties. Like one of it is, I am taking spatial variable, that you can understand from place to place, region to region. Right now, suppose what I am saying, the data, if you use any software, SIMA-Pro or OpenLCA, the data is for European countries. That I am using for Indian countries now because I don't have that information. If I burn 1 ton of coal, how much it is generated, that data is not filled in that or fitted in that software. So these aspects also you need to consider when you are talking about life cycle assessment. Here, I think most of you are engineers. In social science, they always talk about sustainability, sustainable environment, sustainable society, and so on. But for engineering, we need number. Without number, we don't have anything. So as an engineer, always also you should focus on number. Like when we are talking about M15 means the strength of concrete 15 MPa or Fe1415. So I am knowing that that number is important. SBC is 150 kP. It is not very good soil. Very good soil has no meaning. So all the time when I say it is drinking water, but that means we say pH is from this to this. We need number. They say qualitatively, but engineers should always know quantitatively. So that's why when you are talking about sustainability, you should go with proper mathematics and find out the values and tell a number, then only say whether it is sustainable or which is better sustainable. So here I am talking about, suppose say I am going for sustainable analysis of a sand. Here I showed you for the sand. So what is that? I have to first see what are the possible sand available. If I got only river sand, I have no alternative. There is no point in doing all this certain analysis. But if I have, then I have to go for it. So that's why you should have an alternative first. Then, if you second step is you have to identify the qualitative and quantitative variables. So those variables are called as indicators, criteria, and requirement. I'll tell these three in detail. And each of them will have also some weightage. Then so I'll tell one by one this indicator, criteria, and requirement. Now come to third step is I assign the weightage to the variables. Hello? Hello? So this assigning the weight I can do through my judgment, or I can use a mathematical process or statistical process called analytical hierarchical process to identify what should be the weightage. So these are the options. Whether sometimes suppose say you are working for a municipality or an organization, he said no, my this weightage should be more, air pollution weightage should be more than the water pollution, and so on. Now next, this finding out the value of each indicator, that is environmental, economy, and society. What I say it as planet, profit, and people. So this one, when I'm talking about environment, I have to go for raw material, energy, fuel, when I'm going for processing of alternate sand. And that due to that, there are some emissions. So after this, I'll come to a mathematical equation. Then in that mathematical equation, I can do some sensitivity analysis, and then only I'll be able to find out the sustainability index. Based on the sustainability index, only I can take a decision. That means this is a sustainable one or not sustainable one. Or if I have two options, which is better sustainable. So that is the today's my talk main emphasis on when you are talking about sustainable something, to do this analysis and tell. Here is what I was talking about. If you see the first, here I was talking about indicator, criteria, and requirement. Here I am saying indicator. I have got requirement is environment, economy, and society. That means your planet, profit, and people. So for that requirement, what is the environmental requirement criteria is there? Air, water, land, and human health. So you know air, water, land, and human health. So these are the four criteria for the environment. So when I'm coming to air, how I know that air is good? So these indicators are ozone depletion, global warming, and smog. For water is acidification and eutrophication. For human health, whether this is environment is good or on the human, I will know carcinogenic, non-carcinogenic, respiratory effect. So these aspects are known as indicators. If I want, I can add more indicators also. And land is ecotoxicity and fossil fuel depletion. Like when I'm talking about ecotoxicity, the land is getting toxic. Fossil fuel depletion means I am taking out natural resources. So one example I said fossil fuel depletion. So this is for the environmental criteria you have to, environmental requirement, you have to take these criteria and these are the indicators. Similarly for economy, what I will do, suppose we are doing a project and we are using an alternate sand. So I am talking about example of sand. So when I am going for that machine, I am crossing a machine or excavating from river. Both way I am getting equipment. For that I need some infrastructure, I need energy and maintenance of the equipment. So that is called as direct cost. Indirect cost, I can add the environment cost. That when it is running, how much it is affecting the environment, and that is costing how much to the this economy. Then benefits. Who are getting benefit? Suppose I am crossing that, I am getting sand, which I am selling by this amount. So that is revenue. Some people are getting employed, and also I am conserving the river sand. So that is the resource conservation. Indirect benefit, I am making the awareness that river sand is precious. Let's keep it for future, because that is the basic goal of sustainability, competency and welfare. Now, similarly, when I'm talking about social, so this you have to get it through a social scientist or you have to make a survey. I'll tell you one detail later on. So you see, Social could be social individual. I'll ask individual person that if I am going for a crusher with crusher sand here, or I am extracting sand from other place, how it is affecting your life? Is it decreasing the crime rate? Suppose say sand crime is there, sand mafias and all there. So if I go for crusher sand, this may reduce the crime rate. Over health, financial, safety of workers, and all these things I can add to individual. Then based on the socio-economic. In that local economy, if I put some crusher, some people are getting, engagements. So this will help the local economy, employment will there, and all these things. Similarly, socio-community. So is it helping me? The community people are coming together and saying that let's save our river sand and let's use this cross sand. And finally, socio-environment. Using this, what I have done, suppose I am taking out sand, there is a depletion of the, suppose say, there is a side of the shore of the river bank is collapsing. Due to that, maybe aquatic life is affecting. But if I do all these things, maybe I'm not affecting that environment. So if I'm going for a cross sand, so this is helping me. So this you need to calculate. So here if you will see this, all these indicators, I'll say that you have to get it. First, how to get it? Environment, you have to get it through a software called LCA, Life Cycle Assessment Software, CIMA Pro, or you can get it through Open LCA. So CIMA Pro or Open LCA. Economy part, you have to, being a civil engineer, we can do like estimating and costing. So there we can do calculate based on that, suppose the equipment, how many hours it runs, what is output of it, how much diesel or petrol it is taking. So accordingly, I can calculate all these things. Then this is more important, which is social aspect. So this for a civil engineer may be difficult. So that's why you take help of the social scientist. One here we have tried one. So how we have done it, I will tell you. So now next. So once I said you this part that I requirement criteria indicator, that's how to get this weightage. Weightage called analytical hierarchical process. So this is analytical process, that is if you go to the literature, that is by Sati. So he has given a very good formula. Formula in the sense, he said you collect the people just the statement. Like if I ask which sand will be better? So some people will say, oh, river sand is very good. Another will say, river sand will be good. Then another will say, river sand is bad or worse. So then how to tell it? So we have to put a number. So Sati has given that formula, how to give a number. And if you do survey for 400 people, 300 people, then you say that what they are saying and which is they are saying. Some you will ask which sand is better. Somebody will say river sand is better. How better? It is very good. Another will say this is little better than the other sand. So all these little, small, this whatever your qualitative words can be given a number by using this AHP. So I don't want to explain it, but there you have to form a matrix. The matrix formation and formula it is there already in any textbook. So for that, after the development of the matrix, you can find out its eigenvalues, and based on the eigenvalues, you can say whose weightage is higher. Like if I say now, if I say if I go to a place, I'll ask them which you give importance. Some will say our importance is economy. Some will say social is more. Some will say environment is important. So I will collect the data and then analyze it using Sati. I will be able to know, as per their statement, whether this is 40%, 30%, 30%, or this is 40%, 30, or like this, 33, 33, 33, and so on. So this way, you should do this analysis, which is called analytical hierarchical process. So this you should learn, which is not very difficult. One day you can learn it also. And nowadays in Microsoft Excel also you can do it. Next, this same thing what I have done that one, in particular For reverse sand and cross sand, I am saying here. So when I'm talking about analytical process, I said indicator, I got it. Now I'll go for the environment. In environmental, if you see, for life cycle assessment, I'll go for LCS. This is some other software also there. For economy, cost benefit analysis I'll do, and social survey, this one. And these will give me a function, that means equation, that I'll show it here. You see here. Indicator, from indicator to criteria, criteria to requirement, requirement to sustainability. So indicators are environmental indicators, economic indicators, and social indicators. Each indicators I'll get a value and then weightage. And that value into weightage, summation of I to n, this will give me the indicator for the, this for the criteria level. So from the criteria level, I'll go to again. Sorry. So then what I'll go for, I'll get the criteria. So again from the criteria, for each criteria, again I'll put this one, weightage. I'll get the requirement. Again the requirement, I'll put the weightage. I'll go to the sustainability. So this is a simple mathematics to say and get a value called sustainability index. You have to do it for reverse sand, and it is another for the alternate sand. Whichever has got higher, it is better. The sustainability says about the higher value is better. So here I am showing one example. This is for the river sand with OB sand. This is all the analysis we have done. For social aspect, we have taken the data for around 456 people survey. LCA we did using SIMAPRO, and cost analysis by taking quotations from the companies who are going for cross sand, and river sand and all these are available in the CPWD, so you can get it. So look at the environmental aspect. So environmental impact, if you will see OB sand and river sand. So most of the cases OB sand will be less because global warming, smog, acidification and fossil fuel depletion, OB sand is very less because we are using whatever has been crossed, broken from the coal mine. Then I am crossing it. So its impact is less here. Then this is for the cost. This is analysis we are talking about, suppose 100 ton per hour capacity plant to cross it. So once I do that, so assuming 10 years life period, you can this way, you can reverse and no investment. So only in this cross sand we are having the investments. And for the direct indirect benefits, we have taken the questionnaire from the people with taking their -1, 0 to 1. Somebody said good, somebody said bad, somebody didn't say anything. So accordingly you have to give a number because engineers need a number. So this way we can get for environmental cost for ton of river sand compared to OB sand. So river sand cost is more compared to OB sand, environment cost, because river sand is formed with such a long period of time, and if that natural resource is not preserved or conserved, it becomes a difficult situation for the future. OB sand environmental cost is not more. And then we have also social impact. So for this social impact, I'll just highlight few words. You see, we have taken from academic and researchers. First, when you make the question, you have to ask the experts, is this question okay? Is it going to get the information from the people? Because social scientist people know how to get your views and they can interpret and say what you want. So we have taken help of the social scientists. Then we make a questionnaire, send it to different experts, those who are working on alternate sand. They will say, yes, it is good, or they will say, no, your questions are biased. You want to give a preference to a OB sand, so which is not good. You are not considering the other aspects. So all these you have to take their views and then give the questions. And when you are giving the questionnaire, you have to see also different, I mean, people from different aspects, those who are involved in this should be considered, like local public, production supply, those who are contractors and so on, those who are working in there also, and some other, those who have no relationship with this type of things. So all this information you have to collect, and then you can find out the social rating, what they are saying. So this is, I was talking about, this is for river sand, this is for OB sand, river sand, OB sand, and so on. This is SI means socio individual. OB sand के अच्छा rating दिए. Then similar socio community, socio environment, sorry, socio economy and socio environment. So this way you can get that social 4 aspects are there. 4 aspects also you can get for OB sand and river sand for alternate sand. Well, here I am talking about OB sand. Then this is what I was saying, hiding the eigenvalues, that is giving the weightage. I can find out what are the indicator weightage. So this is Satis method. So this is for environment indicator, economic indicator, this is what I have got. So this is not this problem. Once you get the information from there, you just put the values. One thing I can only say, here you see, if EC1 1, and EC1 with EC2 3, EC1 with EC2 1 by 3. That is inverse of it. If it is EC3 with EC1 1 by 3 here, that is EC1 with EC2 with 3. This is the formula for surface. And then you know how to find out the eigenvalues. Okay. So this way, for social sustainability also, we have to calculate, find out the eigenvalues, and based on this, you can find out its preference value. This is for the preference value. So now what I got, these are the preference value. This is for indicator is air quality का 3 था, so air quality 3 indicators, preference value, but so accordingly I'll give the weightage and weighted for criteria, weightage for indicators, and this way for this is for river sand, this is for OB sand. If I get in combination, I'll go for next for this criteria. First is indicator, this is for indicators, then this is for the criteria. So criteria में air had got 3 indicators, but 1 criteria, that is air quality. Water has 2 indicators, 1. Human health has 3, 1. So like this, I'll get the weightage for the criteria. So then next, this way I will get weightage for this. Then criteria by requirement. So if I'll go for the requirement, and then I'll get the sustainability index. So here I'm showing you one example. If I'm considering 3, I've got environment, economy, and social. Suppose here I'm saying equal weightage if I give it. Which has got higher sustainability index? OB sand. In environmental also high, economy, social is much more. So I am finding OB sand has got higher sustainability index, means better. And value, that is 0.6, suppose I have written 0.35, so value I have to mention. If I change this, weightage I change it to 60% social, 20% environmental, ecology. What has happened? So this criteria somewhat changed. So this has reduced, but still all the time OB sand has got better weightage. Only this, I mean, this value what you are getting may get changed, but overall OB sand has got best sustainability index value. So then only say that OB sand is more sustainable material compared to river sand. So this is what my point was, that when you give this statement, you have to do all these things, then only you can give the statement. Okay, this aspect I will not discuss because this will be more difficult for you. Now you don't know more about uncertainties. Okay. Now I am coming to some technical part. Like there I am talking about all the OB sand, and then I made a sand, process sand. I saw that OB sand is better. Now I am to use it. So when I'm talking about the construction material, OB means from the coal mine overburden. Those people also make their own road. So that is called haul road. Haul road is the road used for mining. Hauling means moving the material. So if I can use that, then my transportation cost is saved. I don't have to get material from outside, and also I don't have to transport this material to outside. So that is the first requirement by default. I can say that this will be better sustainable. So first try was that, can I use it for as a haul road? Some of you might have heard about it. This is for the mining, and you know the tonnage of these trucks, sometimes it is around 400 ton to 450 ton also it can go for. In comparison, in our national highways, you can say 35 ton to 70 ton or 100 ton. So this way, just imagine how much load it is there in. So for that, if I can use this material, so for that what you have to do, being a civil engineer, first you have to study the material as a technical feasible solution. Here I have said this is all retained on 70 micron sand, that is for the sand. That is OB. Here I am talking about. So now that I have calibrated that if I make a sand draining, how much load it is required for sample preparation, what is the density in get, and so on. Forget about this one. So now again, when I'm talking about, you might have heard about IRC 37, that is for National Highway Flexible Pavement. But for the haul road, that severe business will not do. Here, what you have to go for, you have to go for a mechanistic based model. So mechanistic based model, and what we found, only OB will not help. So we try to first go with some cement. 1, 2, 3, 4, 5, 6. This alternative cement proportion we went to find out which is the optimum cement percentage. So based on that, we found a compression test, static triaxial test, and cyclic triaxial test. Those who are dealing with roads, they might be knowing all these IRC 37 has that cumulative static axial load. So that is based on which they are calculating. So that's why the material, how much cycle it can go. So my more mechanistic based model should consider these things. That is called cumulative standard axial load, might have heard about now. So for that reason, here we have considered a ASTRO specification, that what's the equation to find out the different layers of the sand. That also I am not going, you can do it. And based on that, you can find out the different layers. Once I say my OB sand is satisfying my criteria and I am able to do it, then here if I go for a life cycle assessment, so then I have to consider this for natural resources, I have to extraction. For that, you have to do eco-electricity and so on. Coal mine overburden, already extraction is there, I have to process it. So due to this, there will be an emission, and when you are sand or gravel or OB, whatever you do it, then for transportation also, you need fuel and you need emission. So when in the batching plant mix it, there also I need electricity, and when we store outside, that is also transportation on site required, emission will be there. For pavement construction also, you need machineries, there will be emission, you need fuel. So all these things, it is a boundary if you are go for environmental impact. So that also you have to say what is the length of the highway, 5 kilometer, width of these 2 lane, 2 ways, subgrade resonant modulus is 69 MPa, and cumulative single axle load is so much. So for this design, I have to consider 2 different materials. When I do that, first I have to see how much material is required. Based on that material, what I found, natural aggregate, if I am going for sand and gravel. Another is if I am going overburden, that is mine over OB sand or OB gravel. So how much is required? So based on this, for different binder code, stack code, and so on, I got it. And the distance, I say distance, suppose is same, keep it same, and then I will compare it. So keeping all this now, I will go for the strength value. So we do UCS value. Then with the curing, what is the change in UCS value with different percentage of cement, because you need to calculate a particular optimum. When I'm talking optimum, not only based on the strength, you have to also durability and also talk about sustainability if you can. So the idea is now, initially it was only the value if it is satisfied by. Next is durability. Then now I am considering adding the sustainability also. So these are the values for different days, how much days you can allow the traffic to stop. Accordingly, you can design that pavement. So these empirical models, I am not going for it, because this model you can develop, you can find out, propose what should be the strength after so many days with so much percentage of cement. Then you need to also see the triaxial shear strength. That is also done. And accordingly, you have to find out the Young's modulus, because in mechanistic model, you need modulus, that Poisson's ratio, and E, not only the severe value. So this is, then you have to go for a cyclic triaxial test. After what number of cycle, what is the residual strength, or that is called plastic strength. That is what we basically, people have done for you, and IIT 37 have simplified it. So this is the, that strength, you can permanent strain, you can get it, elastic strain and permanent strain, you can get it for untreated and treated. So strain was more, and after treatment, the strain has reduced. So accordingly, so you need stabilization, that we found. And this part, you can do it if I want to explain, because my emphasis is on sustainability. So I am not explaining this view on the stress and hysteresis loop. But you have to do this. That's what my idea of telling you and showing it to you. So based on this, we can develop a model for the plastic, or sorry, that is a permanent strain. We can say it's a plastic strain. So this permanent strain model also you can find out depending upon the cyclic Levator strain and with respect to atmospheric pressure. So for different frequency with different confined pressure sigma t, we have developed this expression for this strengths. So this we have done it, and then resilient module also how it varies. You can find out at different odds and different confining stress, it will vary. So you have to be very particular what type of road you are designing, and accordingly you have to get it. As I was saying, another aspect of any stabilized road is the durability. So there are two. One is called mass loss, other is called strength loss. So in the mass loss with 2% is a sudden loss, but you will see after 3, 4, 5, 6 almost not much change in the mass loss. This is also called durability, but in terms of mass loss, ASTM standard you are following. So there it is mentioned how much is mass loss or how much is the strength loss. So for this you have to do 12 cycles wet dry cycle, and you see when I am going for 5%, mostly the values with comparison to that of 28 day cycle curing. So these 5% I can consider because there is not any reduction almost. Otherwise, from 2, 3, 4% there is reduction in strength with alternate wet dry cycle. Then nowadays you can do also, you have got flaxes, flax, and so many things, abacus, ANSYS. So you should make a model, three-dimensional model, and check how much is the displacement of your pavement, including subgrade. So that you'll see subgrade, subbase, base, and subsurface. I mean surface. All this deflection you can calculate. Accordingly, you can say that it is satisfying your requirement or not. This is one more thing this is for the coarse aggregate when I am using for uh, road. There you need to do all these things. That based on the mass loss, you can say for what type of surfacing you can do. And once when I'm talking about based on impact or based on abrasion, this will be able to tell you where you can use it. Okay, this I'm not going for. Deflection is for the abacus. This has been done with abacus, maximum deflection. This is the requirement of FEM analysis, but this is what? This is based on the existing model, and this is based on the abacus model. So this I am going for finally. After doing all these things, again I'll go for analyzing the different sustainability aspect in terms of natural aggregate and OB sand. So these are the different parameters for this is only for environment. I have considered only one environment, suppose economic and so also you can consider. So in the environment, we have considered this global warming, smog, acidification, eutrophication, risk for water and carcinogenic, non-carcinogenic respiratory. This is for human health and possible natural resources. Some few parameters I have considered. And what it says, outside is high, I mean it is not good. If this is small in between, it is better. So look at this. This is for OB sand. It is here towards this portion. So it's better. In ozone depletion, global warming, smog, and so on, except respiratory effect, OB has got higher impact than the respiratory. So this may harm you for the respiratory. So this way you have to do analysis, and finally you can say you may be technically better, but still if found suppose environmental not accept, I mean not admitting, so then you can go for it. And then further economy and society is there. Okay. Then another one is suppose say I am going for this arch material. So when I am talking about this material, so I first need to go for cement mortar, whatever say concrete. First I have to say whether it is alkali seal that innocuous or deleterious. Deleterious, if this value is here, it is deleterious. Nothing, no value is going towards even potential deleterious also. All are innocuous. So that means OB can be used as sand. But the problem is here. Flowability, if you see OB sand, even 0.6 also it is not becoming flow compared to standard sand. Standard sand 0.6 you see it is able to flow. Standard sand 1, standard sand 2. With ferrochrome slag also I am able to get flow. River sand you see more flow. So this is becoming a dry flow with 0.6% water content. So these aspects you need to study when you say you are going to use it for the mortar or concrete. So here we have done for one mortar. So this is done for as per ASTM. You can do also for BIS. So that is for S-type motor or M-type motor. So most people say 7 days or they have got 90 days accordingly. Compared to river sand, the value is less, 0.6% and so on. But it still can be used. The value is become 15, 17 like M-type motor also it is there. Another aspect of it is that we want to study that if this sand creates any void in between, that you can do using ultrasound pulse velocity. And there I found that the strength increases, the value is also increasing, and 3000 is a good value. Next, you need to also do durability test. So in the durability test, you can go with a slag durability test. We have done it for different material, including OB. OB has got very high value. And then also you can go with depth of carbonation. Carbonation chamber test, you can do it. So because you are going for durability. This is for the river sand, this is for OB sand, and this is, there are two different types of OB sand. We have taken OBSS and OBM because somewhere it was looking more like a combination of clay, I mean shell and sandstone. So that's why I give it different name. Okay, similarly also RCPD test we have done it, and obviously OB standard sand was very less, OBSS was less because this was a sandstone type value was less in compared to OBM2. So we were saying that when it is coming from sandstone type OB, it was better. Then we have done this again in environmental impact value. In comparison to like OB sand, this is river sand. So in the river sand, portion impact was more. Environment is affecting more than the OB sand. So this way, I have come to now show two examples for the OB. I cannot explain in detail all these methods, but if you are really interested, I think I can send it to Dr. Meena Murmu. You can collect it from all these publications, and I can share it with you. Then another one, today just a small example I am saying also, some of you can try for this. Here you see now this ash fly ash. Many people are using this fly ash in different utilization. When I 90 I started, there was no data, and only 5% using, and none data is also not information. Now started from 96, and you see the production is increasing, true. So also utilization is increasing, but in between this is called legacy ash. Legacy ash means these are lying in the asphalt somewhere. So these ash also needs to be utilized. Now the government has started to directly use this legacy ash. Then I made it, so a small BTech student started doing, like, should we use the fresh fly ash or used legacy fly ash? So if I am going for legacy fly ash, you are using so many things. If you are going for fresh fly ash, you are avoiding landfill, and directly you can take it for screening grinding, and you can go for cement plants. Where in this case, you have got a site preparation, you have all this impoundment. Again, you have to excavate, dry, screen, grind, all these things, and then only you can put it into cement or anywhere else use it. So due to this, look at the environmental impact in terms of Indian rupees I am taking, because environmental impact you can go in different ways. So if you are taking from impoundment means you are taking from fly ash pond, its impact is very high, very costly. So instead, if you can use fresh fly ash directly from the plant, send your truck and take it to the site. So that should be the trend, and now uh, people, I mean, still it is not effective, but why I wanted to show it, just to say this sustainability assessment, if you can show it and do it and show it to the policy planner, they will appreciate. Okay. So if I do this way, I am saving almost, you see, 3,000, suppose say 2, 4, 6, 8, 3,800, and here it is 5,400. So 25% extra environmental cost if I am using the legacy ash instead of using from the fresh. This is another aspect when it comes about sustainability and utilization of this industrial waste, like called technology readiness level. How many of you have heard about technology readiness level? Any of you? You can unmute yourself and tell me. Hello? Hello? Hello?
Yes, sir.
Hello? Am I not
Yes, sir.
audible? Okay.
Yes, sir,
So I
audible.
said, okay, so I said, any of you, how many of you have heard about this TRL, technology readiness level? People can respond. Some participants are there because in this online I am not able to know how many are there also. Any of you?
Uh,
Okay, I
yes,
found
sir.
so many participants are there.
Hello.
Yes.
So the technology, new technology, how quickly you can adapt or use, apply for the industrial purposes?
Yes, partially you are correct, because this actually how it can best go to the industry. That is the fact. Then what is there in, as I said, the engineer need a number. So this NASA has given it different stages: 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is the business model. That means then only you can use it. So now most of the your faculty development program, the faculty members, here you see, as an academia, we go up to 4. That is called knowledge development. Then here, academia should collaborate with industry. If we don't do it, so if you look at this curve going down, 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 then up. So from up to down, this is called valley of death. If you don't get collaborate with an industry, so after 4 it dies down. But if that's why I put a bridge. If you put this bridge, it can go up to 9. What has happened? Now try as case, academia people did it, then industry, whether cement industry, they took it, put it in cemetery, or concrete industry, they make it patching plant, they put what they call it, ready mix concrete, or now they are putting in different mine works, embankment, mining industry. So this is a good model of a technology readiness level. Whereas in bottom us, it will say fly ash is successful, but bottom us, still only as a fill material is being used, as a pavement material it is yet to be used, and in cement concrete is not, it's still in the as partial summit of replacement sand in concrete. It is in academia, still industries are not using it. So now we need collaboration with industry. Now these power plants have started getting, which is not possible. I have tried also with bottom earth. Only with bottom earth it's difficult. You can add some partially and do it. Anyway, so this study also you do when you go to a thesis, that up to what I am going for 3 or 4, and then you should try for an industry who can collaborate. So then next student can do it, or you can extend further. So these are for the red modules. Many problems what we are doing with industrial waste have not come far. So far, everything with this business model. Another thing, if you do everything, you have made a business, but unless it is put into Indian Road Congress or IS code, it cannot be. People will not use it. So that's why another important point is standardization. So it is called standardization to industry, what culture is to society. So I also now telling about the standardization. I'm giving a small example. This is my thesis in 1992. I was working on flyers. I had taken 3, 4 flyers. One was Funky in Kanpur, Paricha, Jhansi, other than Navili, Tamil Nadu. I was dealing with 3 flyers in 90. My thesis complete 92. Okay. So 1991 I started, 92 1 year almost. One day, because as I was compacting at each moisture, this is a compaction curve it will look like. Similarly, each moisture content I was taking it UCS value. So this is suppose a UCS value with different, at different moisture content. Yes, UCS value, different moisture content. One day, that cylindrical sample, I left it somewhere outside. I forgot. Then after a few days, I found it is hardly any strength. Then systematically I studied it. I put this something in oven, this is inside desiccator. Desiccator means moisture is maintained. Another is outside desiccator. Moisture is not maintained, not oven, desiccator. So as I am kept in desiccator, you see with the time the strength increases. This is in log scale, imagine. Strength increased up to 84 days also upon. Whereas when I am kept outside, after 40 days, 42 days, strength reduces. This is it. From here to here, so many 0.1, this is 0.04. This is NPA. So much 2.5 times reduced. But here it is maybe 0.3 times increases. So this is the what happens. That means fly ash, as long as weight has got some unconfined compression, that is cohesion, once becomes dry, lose its strength. That I was getting 92. So, but that time I had explanation, but I was not able to convince anybody. So now what happened? How to use it? I was not also knowing how to use it. Well, then this is 2001 actually, revised ISC. So then they said, cover it. So that means in academia, you have to find out that what is happening problem there is. Then somebody, professional engineer will find out the way. So this RDS or railway standard or IRC standard. So then only people started using it, and now you see fly ash being used abundantly. I mean, so much fly ash being used for the embankments. But those days, because of this, nobody was using it. This is does not. I have taken 2000, but this 2001 it first started and utilized. So this way, this is Atal. You are saying what is the full form? Something like AI training and learning, teaching and learning. Okay. So why I said about this standard? Standard is just like you are an expert opinions which has been placed in a documented version. Now you think of yourself when you graduated. So that time you are not knowing that teaching some subject is so difficult. You are not knowing very first day you said that you can teach any course. After going teaching some one semester or so, you could know some courses are very tough to teach. So then you could know that I don't know this subject. So that is called know that you don't know. That is called conscious incompetence. This is unconscious incompetence. You don't know that you don't know. Then you learn. So that is why if you learn further, then you know about it, but you have to think about it. That means every day you have to go prepared to the class. Unless you prepare it properly, you cannot teach. Then a stage comes on a particular subject. Immediately you can go and take a class. That is called mastery. And whatever you say, you can say the wrong thing. That is called unconscious competence. So this is what called the expert. So when we are developing certain code are being developed, so taking so much of expertise into this one, this becomes like the expert document, expert opinion. So this, when as a teacher also, you should understand this. This is called Broadwell stages of competence. And this is also there in medical science. So that somebody says knows, somebody knows how, then he shows for demonstration of learning, then he says does it directly. Again I say, like fluid mechanics, first you solve a problem, learn the equation, solve the problem, then using solving a problem, you can solve numeric, suppose a numeric problem. For solving a numeric problem, you do a consultancy, then while doing the consultancy, you could know that you can develop a different gadget also based on that principle. So starting from an equation, solving a numerical problem, solving a practical problem, and developing something new is also a teaching learning. So for that reason, all these things, what we read in the class and when going to standard, it is taken care of it. So there are two difference I say it here. One we call the code, other is a standard. This is called code, means code of practice. And the code is generally should be mandatory, whereas standard is not mandatory. So what has happened in American countries, I mean British standard, so there is a British standard or British code. So you have to very carefully use it. Because code means that will be penalty or restriction. But standard is a guideline. You may follow or may not follow because it's a voluntary guideline. But once it becomes like part of a tender, that becomes like here, what the BIS says. By nature, it is voluntary, but if it is binding, it is stipulated in a contract. So now, if somebody put that, you have to use fly as brick. Then you have to use fly as brick. That become a binding. Like 12 years, almost 12 years before, people are not using fly as brick. So what I did in one project at an Atal, so I put that fly ash brick is the schedule. That means people, student, that contractor has to use fly ash brick. So then it become a standard that he has to use fly ash brick in his construction. So that way, so when as now when you are doing research, you go all these things pass through TRL, and if you can develop a standard, then your research is fully utilized. And that may take 10 years, but you get the satisfaction that what you have developed is being used by so many people. Fly ash brick has also been done. Anyway, this part I will not, what should be quality standard. Now come to sustainability. Again, I am coming to what this sustainability there is. You know, this sustainability, there is no standard because I am talking about sustainability. I told about test, ASTM bol diya. When we are talking about other BIS, IS code 456 or IS 383, whatever the code available, you can use it. But for sustainability, what are the standards? There are no Indian standards. Only you have to use ISO. This is for environmental management system. It is for the carbon footprint. If you want to find out for any product, you have to use ISO 14064. That is what I was showing that time. And if you are going for the energy management, when you are using different sources of energy, renewable energy or fossil fuel energy, so these code you have to follow. So when you are doing, what I would say, sustainability aspects, you also remember there are standards. Okay, so this part, this is what I was talking about, types of standards. Okay, there are methods of test. If you cannot develop some standard for full also, if you are doing some different test also, try to use a standard on the test also. That will also be useful. So now I am coming to the conclusion so that I can interact with you. Some if you have got some queries. As I said, construction material. Almost all the participants who are joining here, if they are civil engineers, everybody has got interest in this construction material, aggregate, whether it's structure, geotech, whatever it may be. Wherever you will use it, you will use this material. So because the demand is more, now we have to reduce, recycle, and reuse practice. So there it comes this industrial and mining waste. For that, you need appropriate characterization which is multidisciplinary. Because some of the things like when I'm using scanning electromicroscope, X-ray diffraction may not be able to, because that was not part of the curriculum of civil engineering. We have to take help of these chemistry people or material people, material scientists. And now the people initially were saying waste to wealth. Now they are saying waste to molecule approach. That's what I was saying. Individual molecule also you can separate and find out where you can use it. And as for TRL is required, we can do it in academia up to 4. Then after, if you don't go, there is valley of death is there, will fall down like a ladder and snake. So for that reason, we need academic industry collaboration. Then sustainability aspects you have to consider if you have to prove yourself, whatever the study you are doing it is sustainable. So that's why I have told you what is the sustainability part, how to do it. It's initially it will be difficult, looks so much, but as you practice slowly for any small aspect, whatever the suppose you are using any alternate industrial waste as a product, you can use it. And resiliency also I didn't consider here, that also it should be quantified. This again I say standards I need to upgrade with regional global information. Many of our standards we don't have IS standard. We are following still ASTM standards. Here suppose sustainability I am using or we are using IS standards. So all these things with missing with policy implementation is therein. So with this, I will stop it here. I will ask if you have got some queries, you can ask me. Hello?
Participant, please ask any query. Have you any doubt or question, you can ask to expert. Hello? Hello? Participant can ask the question.
Yeah.
Hello.
Yes.
Yes.
Hello, ma'am. Hello, sir. Sir, good
It is
evening.
Yeah.
My question is about amongst the fly ash and
So,
bottom ash,
I'll
which one
rather
is
say,
more untouched? Yeah.
I'll say
Hello.
one by one. So you can open your camera also and say it. It will be more interactive. One by one. Suppose now
Sir,
I say,
actually, I'm in traveling.
okay,
So
okay. Okay, so you said, okay, now be loud and clearly say,
yeah,
Saurabh Naik.
sure, sir.
Saurabh Naik,
Yes, sir. Yeah.
tell me.
Sir, my question is amongst fly ash and bottom ash, which one is more untouched in aspects of a research so that it will be need the more work to done in
You
the
see,
future?
I am the fly ash auditor for this Ministry of Environmental Forest. I am visiting different plants. So
Yeah.
around the bottom ash is 88, 12%, 88% is fly ash. Okay.
Yes. Yes.
So this 12% is reusing unutilized.
Yeah.
88% fly ash they are able to use it. So bottom ash is still not being utilized. This is lying
Okay.
unutilized. So that means more research is required on utilization of bottom ash.
Yes.
Hello?
Yes, sir. Yes, sir.
Okay. Anybody else? Okay. Thank you, Saurabh.
Thank you
Next,
so much, sir. Thank you.
next
Anybody else?
somebody Purumani. Somebody. Otherwise, you can raise your hands also.
Any question you may ask? Sir, if they have a
Okay.
hello,
I think they will
Okay.
say that you can later will share, please focus on lecture. So that somebody has written.
okay.
Focus.
So thank you very much, sir, for your well explanation on environmental impact assessment, sustainability index. This will be benefit for all of us that will working on this topic. Thank you very much, sir.
Thank you.
Sir, please, that PPT is also necessary. for us.
PPT?
Sir, namaskar. Thank you, sir.
Thank you, thank you.
Sir, Dev sir, HODs.
Okay, okay. So you can make your video on, then I'll be able to see you.
Yes, sir. My video is on.
Okay, okay, yes, yes. Hello.
Yes, sir. Okay.
Yes, yes. Actually, now I am sitting in my office. I am not in my chamber. I am in Dean's office. So that's why maybe I could not use this. I had come with this one, what called? Microphone, earphone, but I could not use it. Here there is
Okay.
some issue.
No, but your voice was clear, sir.
Okay. Because some feedback was there initially, something was not audible.
No,
but
in the
then
meantime, there was, I was, there in the presentation. Sometime your mic was unmuted, muted.
Okay, okay. Oh, by default maybe, because when the problem is the screen, once I make it full screen, I am not able to know. I mean, what is the status also? In Microsoft Windows, Teams, that is a problem. In other case, you can see here, but this window gets, once I make it to full screen presentation, this is nothing is visible.
Yes, sir.
Okay, so everything is fine.
Yes, sir. Yes, sir.
Thank you.
Thank you, sir.
Okay, then. So I think we'll proceed for the next session. Today's session is over.
Yes, no, sir. Dev sir session is there.
Okay,
Now,
okay. Then I
next
should not
speaker is
enter
Dev.
into somebody else's session. Thank you. So if some feedback is there about sharing what I'll do in the PPT, I'll share all the links. Can recycled fully replace neglected in the concrete without compromising with the quality? Prithviraj. So I can say that it cannot, because if it would have been something, it is not possible. So it has to be, because whatever the existing natural resource was there, it is well tested, time tested. That's why people are using it. When I'm using for this alternate industrial waste, you have to blend it. Because in one case, I am saying, in one, people try to use fully fly ash for the one RE wall with a strip, aggregate, I mean that steel strips. It was not useful. Only I added 15% sand blended, it worked. So all these, when I'm talking about industrial waste, try to blend with some good material, little bit, 10%, 15%, and so on. This is more appropriate than utilizing it individually. That's my experience in different cases. So I'll say that much. Okay. Okay. Thank you.
Thank you, sir. Thank you very much.
So I am leaving the meeting.
Yes, sir. And thank you, sir. Now, next session will be by Dr. S.B. Dev, sir. Soumya, any break is needed or we can continue? Hello? No break, we can continue? It is okay?
Yeah, you may please. That will be good.
Okay, thank you very much.
Yes, ma'am.
Okay.
Soumya, you can proceed.
Yes, ma'am.
For Dev,
Very
sir,
good
introduction.
evening to the respected delegate members. I am Soumyaprita Sahani, research scholar from NIT Raipur. Here I am going to introduce Dr. Siris P. Deol.
No voice.
Soumya, your voice is not
Am I
audible. Yeah.
Yes, ma'am. Here
Not
I am going
audible.
to introduce. Here I am going to introduce Dr. Siris P. Deol, sir, who is presently Professor and HOD of Civil Engineering Department at NIT Raipur. He did his BE from VRC in Nagpur, MTech from BITS Pilani in Structural Engineering Specialization, and PhD from VNIT Nagpur from Civil Engineering Department. Sir has published more than 76 papers in international and national journals and conferences. He has organized several workshops, conferences, and delivered many invited lectures. He has guided more than 20 MTech students, 10 PhD scholars, and guiding at present several PhDs at NIT Raipur now. So I am request to Honorable HOD Sir to address the gathering. Please, sir.
Thank you, Soumya. Thank you, Meena ma'am.
Okay, sir.
Yes, sir. Now we can proceed.
Yeah, I'm just trying to actually recently I have not been using this, so how to share that just I'm
Sir,
checking.
near the leaf, share button is there. Near the leaf, share
शेयर
button.
बटन है, उसके बाद में
हाँ, share.
हाँ
Share the screen. Maybe it is come.
स-
Share. Whenever we'll click the share, then screen will. Okay, now it is came, sir. Your PPT is visible.
ओके पीपीटी बोर्ड में है मैम.
हाँ है सर. Full screen, sir.
हाँ फुल स्क्रीन कर लेता हूँ. Is it visible to you?
Yes, sir. For
Slides
participants,
are
it is
slides
going
are
on.
changing.
Yes, madam.
Changing, sir, changing.
Okay, thank you. So, good evening, everyone, and I am thankful to you for being so patient for this lecture at such a late evening, I should say. So, thank you for that. My request to all the participants is if there is any question at the same time, you can ask the question because that will continue your focus on the presentation. Else what will happen is if we are actually not able to understand one part, then rest of the part as well remains unanswered or unclear to us. So you can ask the questions if you wish during the presentation. And if you can write it down and ask at the last moment, that will be even good. So let us start today's presentation, that is sustainable and high performance self-compacting concrete. Generally I like interactive sessions, but today because we are online, I may not be in a position to have interactive sessions. What was the motive behind self-compacting concrete? So the sole motive behind self-compacting concrete was to make concrete structures sustainable. Now, sustainable is a jargon, I should say, because different people have different view on what is sustainable. So let us try to understand it from the point of view of concrete. So in concrete, we call something sustainable if there are few conditions. Like, as we all know, cement is means manufacturing of cement actually 1 ton of cement produces 1 ton of around 0.8 tons of carbon dioxide into the atmosphere. So if we can save the use of cement, we can call that as sustainable. Another way of making structures sustainable is to make them durable. Durable means the structure which I have made, it will keep performing for maybe 50 years, maybe 100 years, or even maybe more. There are a lot of structures which are standing. For example, I always give this example of our institute building, which is 60 plus year old. Yes. So if I consider that as sustainable, then what we could achieve was after 50 years, still the building is giving service to us. So what does that mean? The requirement of new material for making that building is saved. Yes. So anything which will save the material for future generations can be called as sustainable. So why self-compacting concrete is sustainable? The motive of Japanese engineer to produce a self-compacting concrete was durability. Now you will say self-compacting concrete is all about workability, from where durability has come. So a comprehensive study was done by the Japanese engineers, and they found that even if they are doing everything right for producing concrete, the person on the site is not doing his job well because of various reasons. He may be tired, he may be working in difficult situations, something like that. So he is not compacting the concrete well. And that is what is resulting into poor durability or poor performance of their concrete. Now, if we see human behavior, so human behavior is not constant always. What generally happens is in the morning, I am full of energy. I may be doing my job very well. In the afternoon, I may have lack of energy. And in the evening, maybe I may not be having any energy. Yes. So the laborer who is doing a very work may not be putting his 100% in the afternoon or in the evening. So the thinking behind self-compacting concrete was the engineers decided that they will need something which is constant throughout the day, throughout the week, throughout the year. And that brings us to one of the very, very important aspect of self-compacting concrete, that is gravity. So in simple terms, self-compacting concrete is a concrete which can be compacted only under the force of gravity. Yes. So when all of us know that durability is a reflection of permeability of concrete. So if concrete is impermeable, durability is going to be very, very high. And if concrete is permeable, durability is going to be very less. So from this point of view, when the concrete is able to compact itself under gravity, whether you do concreting at 8 a.m. in the morning or 8 p.m. in the evening, concrete is going to be very, very impermeable. That is why it will be very, very durable and the structures will last for a very long time. You all may be aware regarding the Petronas Towers. That is one of the very, very good or remarkable structure which is available in the world. And on record, it is having a service life of 125 years. Now, this is something which is very, very remarkable. So this kind of durability is only possible when you are having a properly compacted concrete. And proper compaction is possible only with self-compacting concrete, unless the person standing at the site is very, very particular regarding compacting the material or concrete. So this is all is, I should say, brief history of self-compacting concrete. And that is why the self-compacting concrete, for the durability reason, is becoming very, very popular nowadays. And I should say its use is increasing in India very rapidly. So this is the overview of the presentation. Most of these points I shall be discussing in the presentation. So self-compacting concrete is highly flowable, non-segregating concrete that fills uniformly and completely every corner of formwork by its own weight and encapsulate reinforcement without any vibration while maintaining homogeneity. Now here, just to give you an idea, workability is a very difficult term to understand. Why I am saying very difficult term to understand? Because if we define it, it is the ease with which we can compact the concrete. So there is no technical term which is involved over here. Ease for me can be different, ease for you can be different, and that is why it is very difficult to come on the same platform regarding what is ease. And that is why gravity is the only force for compaction. Gravity is going to be same for everybody. It is going to be same at every location. So when workability as a parameter to understand is very, very difficult, we have to come to some platform which will remain same throughout. So that is why gravity is very, very important from the point of view of self-compacting concrete. Now, when we talk about gravity, two things are possible. First thing is, if the concrete is very, very fluid, it may segregate or it may bleed. Now, when we are designing a normal concrete, the potential of bleeding as well as segregation is far less. Why we call self-compacting concrete as high performance? So always understand this aspect. Whenever I am doing above average work, the basics needed should be very, very high. अगर मुझे दिन में 10 किलोमीटर चलना है, which is normal by any nature, I don't need preparation. But let us say if somebody says कि आपको 10 किलोमीटर दौड़ना है, then it needs a lot of preparation. So whenever my performance required is very high, like in case of self-compacting concrete, automatically I need to be very, very particular about every aspect. Otherwise, concrete is going to bleed, it is going to segregate. So we should be very, very careful in self-compacting concrete. Self-compacting concrete nowadays is used in all the structures, let it be precast, let it be cast in situ. In both the cases, self-compacting concrete has become very, very popular. So it is preferred for sections with highly congested reinforcement. Now, just for the benefit of everybody attending over here, this is the extreme case taken from internet. Now here you can see the reinforcement is so close to each other, hardly there is any space for aggregates to move. Yes, so from that point, if you see, we need something which can flow very easily into every corner or between all the reinforcement. Otherwise, what will happen? RCC is totally dependent on a good bond between reinforcement and concrete. And if we are not able to put good concrete quantity into such a heavily reinforced section, finally the section is going to become very, very weak. Just to give you an idea, after earthquake, most of the beam and column joints, they fail. The reason is very simple. When earthquake occurs, there is instant surge in the energy of applied to that structure. And in that case, ductility of the structure is of immense value. So if the structure is ductile, it will survive such a surge of energy. Now, what do I mean by ductile? Reinforcement is ductile, concrete is brittle. But if both of them are separate, concrete is going to actually crumble because it is brittle, and reinforcement is going to buckle because it is very, very ductile. Yes. So if in such a case where reinforcement is so high, we are not able to put the concrete well, what is going to happen? We are actually going to have a very poor bond between concrete and reinforcement, which will lead to such a poor joint and finally into such a failure of joint. So any earthquake affected structure, if you visit, mostly the damages will be there at this kind of structure. So in this is extreme case, but in normal condition as well, we see for the purpose of bend means for whenever the reinforcement from beam is bent and it is put into the column, there is very high density or very high number of reinforcements at that column beam joint, and that makes very less space available for concreting. So such a location is always, it is desirable that we use a self-compacting concrete to make that structure, means the bond between reinforcement and concrete well. Area with restricted access to placement and consolidation. A lot of times laborer are working in very difficult situation. Either height is very high or the space between two locations is very less. So because of that, what will happen is concrete is going to be, means the compaction of concrete is going to be very, very tough. So in that case, we just have to actually use the self-compacting concrete. A lot of times, architectural requirements are such that the thickness of the section is very, very less. So when thickness of the section is very less, if we use normal concrete, then compaction will become very, very difficult. There is a new type of structural member which is becoming popular nowadays, and that is hybrid structures. Or hybrid structure means the tubular steel tube is filled with concrete. So in that, it is very, very difficult to compact the concrete, and hence we just need to use self-compacting concrete over there. And as I in the introduction, as I said, whenever we want higher durability. So those participants who are from Raipur, the Secretariat building is produced with self-compacting concrete. The only reason for using self-compacting concrete there was that we needed that public structure or public building to serve for a very long period. So in all such cases, we need to use self-compacting concrete. Here you can see there is a nicely flowing, just like a fluid material, which is concrete. Now, the people who are actually compacting over here, they are not compacting, they are just leveling the concrete. Yes. So it is not that self-compacting concrete will need somebody to even level, but if we level that, the level will remain same. Otherwise, there is no need of compaction. So you can see, just like a fluid, it is moving into all the corners of the reinforcement as well as formwork. So very beautifully, we can see the performance of self-compacting concrete. So most of these introductions I have already discussed. These are the advantages. Faster construction in India. Few constructions. See, when the construction volume is very high, even sufficient labor is not available for compaction of the concrete. So in such cases, self-compacting concrete is preferred. COVID-like situation wherein laborers are not at all available on the site, but let us say contractor has to perform the concreting. So what he can do is he can very well use self-compacting concrete, which will require minimal number of labor and concreting can be completed. So manpower can be reduced, very good surface finish. Nowadays, self-compacting concretes are also produced with certain patterns. कहीं पे पत्ते बना देते हैं, कहीं पे और कुछ बना देते हैं. So all such kind of patterns are also possible in case of self-compacting concrete. It is very easy to finish. It has good durability, greater freedom in the design. So architect can design it with very small thickness of structures. So that is possible. Thinner concrete sections are possible. In India today, we are not much bothered about the noise levels. So mostly whenever construction site is going on, we hear a lot of noise from that. It disturbs our daily life, our work life. But in India, there are no restrictions. But in foreign countries, there are very strong restrictions when you are working in commercial or residential area. So when we use vibrators, it makes a lot of noise. So to avoid or cut that noise, contractors in such countries are forced to use self-compacting concrete. Again, vibrators are sometimes dangerous for the labor who are working at the site. So in such situation, when we are using self-compacting concrete, it is safer for the workers. Now you will say, ki, sir, if self-compacting concrete is such a good material, why we are not seeing self-compacting concrete used everywhere? So there are multiple reasons. Because of higher fine material content in self-compacting concrete, it requires very good curing. If we are not able to cure it well, it is going to cause shrinkage cracks, and finally the durability and strength both will be affected. Another issue is in today's condition, self-compacting concrete is costlier. So the cost may vary according to what is the requirement of self-compacting concrete, but cost can be as high as 20%. Yes. So the owner who is not so much focused on self-compacting concrete may not like to put 20% extra cost for producing self-compacting concrete. Thirdly, there is requirement of expertise in self-compacting concrete. So self-compacting concrete requires very high quality or very high shear mixers for mixing the concrete, and it also requires a very good knowledge regarding the concrete and concrete making materials. Just a slight mistake or just a slight change in anything can result into very poor self-compacting concrete. Very poor means bleeding and segregating self-compacting concrete. So that is why a lot of people who are not very familiar with the various materials, they don't actually go for self-compacting concrete. They prefer normal concrete and they compact it with compactors. So why the self-compacting concrete is called as high performance concrete? So first is method of placing. So only gravity is the force for compacting the concrete. Now, because of this, the mixed proportion of material is very different than the normal concrete. Yes, so a lot of people have this misconception that in normal concrete, if we increase the percentage of superplasticizer or percentage of water, we will have higher workability, and higher workability of, let us say, 200 mm slump is self-compacting concrete. No, this is not right. We should not get into such things, because at the end it will result into poor concrete performance. Conditions under which it is placed. So you all may remember the photograph which I have shown you in earthquake zone, wherein the reinforcement is very, very high. I gave you example of Secretariat. So Chhattisgarh Secretariat building is actually produced with self-compacting concrete for higher durability. A lot of people think that self-compacting concrete has to be high strength concrete as well. No, we can produce a M20 grade self-compacting concrete, which is very well possible. Now, caution, I have mentioned it with red. Very, very important point to remember. Due to poor mix proportion, self-compacting concrete should bleed and segregate, reducing strength and durability. So if not properly produced, or if we do not take care of the properties of various ingredients like coarse aggregate, fine aggregate, and cement, we are going to have a bleeding and segregating mix. Now, from workability point of view, the surface area, water present in the coarse and fine aggregate, water absorption of the coarse and fine aggregate, all these things are very, very important. If we make any mistake in calculation of any of these things, then we may result into a bleeding and segregating concrete. This is the introduction part, which mostly I have discussed. So Japan introduced self-compacting concrete for durability. Now, as in the beginning I said, if something is durable, we may call that as sustainable as well. Earthquake resistant design is nowadays becoming very, very popular. You all must be aware that now in India as well, we need to design the structures with ductile detailing or for earthquake resistance. And what does that mean? There is increase in the percentage of reinforcement. And when the percentage of reinforcement increases, automatically we need to have either proper compaction or we need to have self-compacting concrete. Now, this is a heap of aggregate, coarse aggregate, which we can see. So now let us try to understand what is the difference between the normal concrete and self-compacting concrete. So this heap of aggregate, let us say if I mix it with water in a mixer. So what is going to happen? As soon as I discharge this material from the mixer, water which is very fluid, it is going to flow, and aggregate which is very big in the size and which is very heavy is going to remain at the same location where it was delivered. So I hope this concept or this visualization you are able to have, because this is a very, very important concept in understanding the self-compacting concrete. In case of normal concretes, our thinking is if viscosity is more, workability is going to be less. So to make concrete more workable, we make it less viscous. Viscosity means it is the property of cement, water, and mortar to carry the coarse aggregate, which is a heavier and bigger material. So in normal concretes, if viscosity increases, for example, when I am shifting from, let us say, 0.4 water cement ratio to 0.35 water cement ratio, I am actually making cement paste more viscous because water quantity is less. So in case of viscous concrete, we will have lower workability. But in case of self-compacting concrete, we need lower viscosity. Because if the viscosity is not low, just now I gave you example that if I mix coarse aggregate and water together, what is going to happen? Water, which is very fluid, less viscous, it is going to flow immediately after discharging from the mixer, and coarse aggregates are going to remain at the same location where they were discharged. So the important difference between normal concrete and self-compacting concrete is we need to have viscosity in the mix along with the flowability. So we want the mix to flow. At the same time, we want the mix to be viscous so that it can carry the coarse aggregate. If just another example which I will give for the importance of viscosity, let us say if there is a container in which water is only present, and if I put a coarse aggregate which is a bigger particle size into it, what is going to happen? It is going to immediately settle to the bottom, which we will call as segregation. Yes, but let us say if in the same thing there is bitumen. So bitumen is viscous. Now, if I put on a container having bitumen, a coarse aggregate, bitumen, because of its viscosity, will not allow the aggregate to settle to the bottom, may not be immediately. After a certain time, it may happen, but immediately it will not allow the aggregate to settle down. So aggregate will be somewhere in between. So that is what is required. In self-compacting concrete, we want all these materials, coarse aggregate, fine aggregate, cement, water, they should remain cohesive with each other. It is not that aggregate separates and settles down and rest of the materials remains at the top. So that is not there. So important design requirement for self-compacting concrete is that concrete should be flowable. At the same time, paste should be very viscous to carry the coarse aggregate along with it. This is just a representative, I should say, concrete mix design, wherein we can say the top is self-compacting concrete and bottom is conventional or normal concrete. Now here you will argue ki how it is possible to have self-compacting concrete with same quantity of water. Yes, that is what is shown over here. But that is all, I should say, the magic of admixtures which are available today. So in normal concrete, we may be using plasticizers or super plasticizers. But in case of self-compacting concrete, we will have to use hyperplasticizers or higher water reducing super plasticizers. So then only it is possible. Here, the difference is you can see cement is far less in comparison to the powder. Now, why powder is mentioned over here? Generally, the requirement of fine materials in case of self-compacting concrete is about 500 to 550 kg. Now, as we all know, it is not possible, according to the codal provisions, it is not possible to have cementitious material more than 450 kg. Not cementitious material, I should say cement. It is not possible to have cement more than 450 kg. So then what we can do is we can restrict the quantity of cement, let us say 300 to 350 kg, and rest of the material we can add some pozzolanic material like fly ash, GGBS or some other pozzolanic material. So that is why we will see over here, it is not written as C, it is written as powder. So powder may include multiple pozzolanic materials. Sand quantity is similar, or I should say somewhat more than the normal concrete. Coarse aggregate is less than the normal concrete. Now, why? In normal concrete, around 50% or 45% to 50% is the quantity of coarse aggregate. Now, when you want this coarse aggregate, it is like a baby being carried by a mother. Yes. So if baby and mother both are of the same size, then it is not possible for mother to carry the baby. So here coarse aggregate, which if it is, let us say 50% of the total volume of concrete, rest of the material, that is water plus cement plus sand, it will not be in a position to carry the coarse aggregate of equal weight or volume. Yes. So from that point of view, we have to reduce the quantity of gravel in comparison to the normal concrete. So that is what is clearly visible. So what is the difference? Because we want higher viscosity, we are putting in higher powder content, we are putting in higher sand content, and because we want coarse aggregate to move along with rest of the materials, we are reducing the quantity of gravel or coarse aggregate. So that is what is the change in the design of self-compacting concrete. Now, there are different approaches for self-compacting concrete. There is, I should say, simple method of dividing the concrete into two phases. The first phase is fluid or paste. That is something which can flow. Yes. Now, when this will be able to flow, it will be also able to lubricate the coarse aggregates for flowing. And phase 2 is friction material, which is coarse aggregate. So here, as I have already discussed, we want phase 2 volume to be somewhat less than 50%, and we want phase 1 volume to be somewhat more than 50%. So that is what is the difference in the self-compacting concrete in comparison to the normal concrete. There is also one important concept of what is called as water or paste film thickness. This is something which is important for workability. So unless the paste between the two aggregates is high, it will not provide the aggregates to flow. Otherwise, what will happen? Aggregates will remain over there. They will not flow. So water film thickness has to be higher. Now, to have this higher water film thickness, we need to increase the quantity of powder. So that is what is important aspect. Self-compacting concrete is fine grain dominant concrete. Now, I will not get into much of the details regarding what is fine grain, why it is important and all. But as just now I discussed, if my coarse grain, which is my phase 2, which is friction phase, if that phase increases, my concrete is not going to flow. So self-compacting concrete is divided into, first is paste, which is water plus powder. Now, powder may include cement, lime powder, fly ash, slag, silica fume, or multiple such fine materials. Water is the only liquid in the concrete which can flow. So we need to have sufficient quantity of water. In normal concretes, we generally restrict the quantity of water to 150 liters. Now, it totally depends on which type of plasticizers are available. If plasticizer or super plasticizer is only available, we may have to increase the quantity of water. to, let us say, even 200 kg per meter cube. So that totally depends on which admixtures are available. Only water cannot carry coarse aggregate. That is what I have already discussed. So along with the flow, we need to have viscosity to carry coarse aggregate under gravity. So all this matter has been already discussed. So what we do is, we have higher quantity of powder, we mix it with water, and then we mix it with sand, considering that we are able to carry the coarse aggregate in this mortar. Normal consistency test for cement could be a very good indicator of paste flow. So we have to understand this. If generally what in normal concrete, what we do, there is a set procedure which is given by IS 10262. We follow that to design. In case of self-compacting concrete, though there are recommendations, but the important parameter is workability. So what we can do is, we can perform the standard consistency test on the cement paste to understand whether the material can flow or it cannot flow. The standard consistency test we have to perform, and with that we may get some idea regarding what is the minimum quantity of water which is needed for making it self-compacting. So as I have discussed, design requirement is lower coarse aggregate content, increased pest content, low water cement ratio. Now low water cement ratio may be required if we need to design high strength concrete. Then viscosity modifying admixture. So viscosity modifying admixture, this is a new type of admixture which is invented. What does that mean, or what is the importance of this viscosity modifying admixture? When I try to increase the viscosity of concrete by adding higher and higher quantity of powder, what is going to happen? Viscosity is going to increase, but at the same time, flowing ability of concrete is going to reduce. Because your water quantity is fixed, if you are increasing the quantity of cementitious material or powder, it is going to make the cement paste or powder paste drier. And that is why the flow of concrete may not be that easy. So then what is this viscosity modifying admixture? They are very fine particles of polymer which are dissolved into water, and this material is added into the concrete. So what it does is, it does not allow the water to remain free in the concrete. So these finer particles, they will hold the water within the concrete and not allow it to bleed. Now, whenever water added is higher, as just now I said, there is a tendency of water to bleed. So the viscosity modifying admixture, very finer particles, they will not permit the water to flow out of the concrete, means they will restrict the bleeding. And then when water will remain within the concrete, it will allow all the materials to flow together. Lot of times nowadays people are using this viscosity modifying admixture even in normal concrete just to avoid the bleeding. So viscosity modifying admixture is a very good admixture for producing self-compacting concrete. This is a water powder ratio. So water powder ratio has to be maintained. This is by volume. So we generally are habitual to water cement ratio 0.5 and below. So you may say कि 0.85 and 1.1 कहाँ से हो गया? So in case of self-compacting concrete, we have to understand this concept. When there is a volume of coarse aggregate which is to be carried by rest of the material. So we are more focused on water cement ratio by volume, not by mass, which is a common practice. So we must think in this direction कि हमको कितना volume चाहिए है for making the aggregates to flow. So from that point of view, volume becomes important. Powder content may be between 400 to 600 kg. Now, if viscosity modifying admixture is used, we may not require such a high quantity of powder content. Yes, fly ash is a very, very good material for self-compacting concrete. Because what is the benefit of fly ash? It is a spherical and glassy material. So glass means very, very smooth, and spherical means it acts like a ball bearing. So that helps in increasing the workability, increasing the viscosity, and also keeping the flow to be high. So that is what is the benefit of fly ash. Along with that, there are other benefits like fly ash is cost wise, it is very cheap. So we may get the benefit in terms of making concrete with very high powder content. If we use such a high quantity of cement, cost will be high, heat of hydration will be very high. Because of that, there will be shrinkage. So all these issues may occur. But if we are actually using the fly ash, then all these issues can be addressed. Fine aggregate content, if you remember, in normal concrete, it is up to 35 to 40%. But in case of self-compacting concrete, it can go as high as 50-55%. But normally it is somewhat higher, up to 45%. Water content I have already discussed. It is going to be somewhat higher. 10, 15, 20% water reducing admixtures may not be useful. We need to have higher water reducing admixtures. Then the second part, that is coarse aggregates are carried by the mortar. Mortar, which is a combination of paste and sand. Now, how this design of self-compacting concrete is different than normal? So what we have to do is we have to make paste so fluid that even after adding X quantity of sand into it, still both of them can flow. So sometimes we may have to redesign this paste and mortar part. What actually happens is our paste is flowable, but as soon as sand is added, it becomes less flowable. So that is why we may have to add higher quantity of paste to make it flowable. So according to the flowability of mortar, we have to adjust the paste. Mortar will have higher viscosity and lower flow compared to paste, but then it has to be minimum as per the requirement of self-compacting concrete. What are the requirements? That I will discuss shortly. Self-compacting concrete may be called as suspension of coarse aggregates in mortar. Volume of mortar should be sufficient to carry coarse aggregate. Volume of sand is generally 50% or more of the total aggregates. So that is what is the change. Final volume should be decided based on paste volume, grading, and density. So when we are talking about concrete, mortar already we have, which is a workable mortar. To that we add coarse aggregate, and when this combination of all the material is still able to flow, then we may call that concrete is self-compacting concrete. Lower volume of coarse aggregates increases surface area and Hence, powder consumption is required. So, as I have already discussed about the water film thickness, so if we are reducing the quantity of coarse aggregate, which is having lower surface area, our total surface area of concrete is going to increase. And because of that, we need to have higher powder content. Final volume of coarse aggregate should be decided based on maximum size. Generally, it is difficult to manage higher sized coarse aggregates. So, though in the past, self-compacting concrete has been designed with 40 mm aggregate as well, but generally people prefer 12 or 20 mm aggregates for self-compacting concrete. Coarse aggregates have higher specific gravity and are bigger in size, hence tend to settle or segregate. Coarse aggregates have tendency to interlock if sufficient lubrication by mortar is not available. This interlocking is very important aspect that we can call as segregation. So we will be discussing about how to check that segregation part. With increase in maximum size or coarse aggregate volume, tendency to segregate and interlock increases. Friction between formwork and reinforcement increases the tendency to segregate. Now, again, if you remember that figure which I have shown or photograph which I have shown, the reinforcement was so high that only mortar may cross that. So what is possible? In such case, we can design a self-compacting concrete with only 10 mm maximum size of aggregate. Such things are possible and such corrections should be made. These things I have already discussed. So these are the ingredients. So ingredients remain same. There is a different requirement of self-compacting concrete, wherein we need to have higher quantity of material passing 120 micron. So material passing 120 micron is called as powder. And to increase the quantity of powder, we can use higher quantity of fly ash, slag, silica fume, lime powder, everything. Water has to be higher, better water reducing admixture has to be there. So all these things are important. As you can see over here, fly ash is glassy in nature and spherical in structure. So you can compare it with cement. So cement particles, they are not spherical, they are not glassy, and because of that, they reduce the workability of concrete. But if we add splash into the self-compacting concrete, so it is very helpful in increasing workability, in reducing bleeding, and that is why people are using it with higher quantity. Superplasticizer, how exactly it works? So it covers the cement particles and hence cement particles actually disperse well in concrete. So when they disperse, they also allow the water to disperse within the concrete well. So considering all this, we will generally have a very workable concrete with the superplasticizers. Viscosity modifying admixture, I have already discussed. For whenever we are trying to produce a self-compacting concrete, we can order to the chemical manufacturer that we want a self-compacting concrete. We want to produce self-compacting concrete. So you add viscosity modifying admixture as well into the superplasticizer. So that type of combination is possible.
That will give them a lot of confidence going into Champions Trophy, which will be played at home, partly at home.
Okay, so there are, as self-compacting concrete is different, there are,
raising the level.
excuse me, somebody's mic is on. please mute yourself. Thank you. So as self-compacting concrete is different than the normal concrete, the testing of self-compacting concrete is also different. So what concrete we call as self-compacting concrete, it needs first filling ability. So the ability of fresh concrete to flow into and fill all spaces within the formwork under its own weight. So this filling ability is checked by a test which is called as T50 centimeter. So T stands for time. Time for slump to attain a flow of 50 centimeter or 500 mm. That is checked. Next is passing ability through reinforcement. So this concrete which is produced, it should be able to pass through the reinforcement which is there at the site. So the capacity of fresh mix to flow through confined spaces and narrow openings such as areas of congested reinforcement without segregation. So it should pass through that reinforcement and it should also not segregate. Not segregate means it should allow coarse aggregate as well as mortar to be present everywhere. Then there is segregation resistance. So segregation resistance means coarse aggregate should not separate from rest of the materials. So that is what is segregation. So for checking whether the concrete is segregating, two tests are recommended by the IS code. One is sieve test and another is V-funnel test. So what is segregation resistance? It is the ability of fresh concrete to remain homogeneous in continuation in composition while in fresh state. And then last property which is needed is viscosity. Concrete with low viscosity will have very quick initial flow and then it will stop. So what will happen is, like an example of water plus aggregate, the flow of concrete initially will be very fast, means water will pass through the edges and coarse aggregate will not. So that is why viscosity is very, very important. So these are the tests which we have to perform, and these are the limits which are given by the code. In case of self-compacting concrete, visual observation is very, very important because visually you can understand whether the concrete is good or bad. Then there is T50 centimeter slump. So flow should take less than 8 seconds to reach 500 mm mark. So what we have to do is we have to measure the diameter of concrete at different locations, and that diameter should be 500 mm and the time taken to reach that should be less than 8 seconds. Lower the time, it is better. Then there is another test that is called as slump flow. So in slump flow, we don't check the time in which it reaches 500 or 600 or 700 mm. In this case, we just check how much diameter of flow of concrete will be. So higher the diameter, it is better. And according to that, 3 categories have been made. So these categories are shown over here and they are useful for different types of construction conditions. Now here you can see on the left photograph, the concrete has, after lifting the slump cone, concrete has segregated or it is at the center only. So this is not a very good self-compacting concrete. On the other hand, on the right hand side, you will see throughout the thickness of concrete is similar. There is no segregation which is observed. No segregation observed means there is no location where the concrete depth is more because of higher quantity of coarse aggregate. So it is not possible. So this is on the right side, there is a very good concrete. And this way, the way it is shown in the photograph, we have to measure the diameter at least 3 locations. Then there is L-box requirement, then and there is J-ring requirements, sieve test. So the specifications are given over here. V-funnel test and V-funnel at 5 minutes. So I will discuss about this as well very fast. This is the L-box test. So in L-box test, on the right hand side, we pour the concrete into this L-box and then the sliding gate is lifted. Now, if the concrete is very workable, H1 will be nearly equal to H2. So that is a very good quality of concrete which can pass through the reinforcement. Here you can see there are bars which are there. So through these bars, the concrete will flow. And if it is very workable, H1 will be very close to H2. The ratio has to be 0.8, means H2 should be at least 0.8 times H1. So that is what is required. Next test is J-ring apparatus. So J-ring means, as you can see in both the photographs, these are the vertical bars which are welded to a circular plate, and concrete has to float through this. So it is, in simple terms, I can say a float test through obstructions. So obstructions are created because of these vertical members which are there in the J-ring, and then whether concrete is able to flow through such obstructions or not, that is tested. If, as you can see in the third figure at the bottom, at the center the height is very high, that clearly indicates that segregation is there. So what is the specification? Outside the J-ring height and inside the J-ring height, difference should not be more than 10 mm. So that is what we have to see. If the difference is more, it will show that the segregating ability is still there. This is the V funnel. We have to fill it with the self-compacting concrete and then open the gate, which is there at the bottom. When we open the gate, the concrete will flow down. But here, as you can see, the neck is made very narrow. So the aggregates, coarse aggregates which have a tendency to settle down, they will settle and they will block the neck of this V funnel. So if the segregating tendency is there in case of concrete, it will just block the neck, and because of that, the concrete will actually not flow through this narrow opening. So this is what is segregation. And if such a thing is happening, we will call concrete as segregating concrete. And then we may have to reduce the quantity of fine aggregate, or we may have to increase the quantity of paste. So this is all about self-compacting concrete. So self-compacting is very important material to make durable constructions. Hence, it must be encouraged in all important constructions. Higher initial cost can be easily compensated by lower labor cost and higher durability. So even if we are putting more in terms of the initial cost, we will be getting the long-term benefits, and hence we should use the self-compacting concrete. Now, as self-compacting concrete is a high performance concrete, we need to have a very strict quality control for the self-compacting concrete. Otherwise, we are going to have a poor self-compacting concrete. So we must follow the details which are available in the code. Luckily, our present 10262 code has provided us good guidelines for producing the self-compacting concrete. just to improve the workability and to improve the viscosity, we need to use flash, GGBS, and such similar materials which are useful in enhancing the workability of concrete. We have to use higher volume of fine aggregate and lower volume of coarse aggregate for producing self-compacting concrete. The concrete which is produced, it should have filling ability, passing ability, segregation resistance, and viscosity. That should be checked very frequently. And if we fail to do that, we may have a poor concrete at the end of the day. So that is why when we are talking about self-compacting concrete, we should very much use the best quality control practices to produce the concrete. So these are a few of the references which I have used for preparing the slides. So you can also get benefit out of these resources. So thank you for your interest and patient listening. Now, if you have any queries or questions, I am happy to discuss that.
Oh, yes, sir.
Sir, good
Sir,
evening.
Yeah, good evening, sir.
Sir, is there any difference between self-compacting concrete and free-flowing concrete?
That is just another name which is given to the free-flowing concrete. So it is self-compacting concrete only.
Thank you, sir.
Free-flowing concrete means if you see the graph which was there for flow, we have different ranges. 550 to 650, 650 to 750. So when we are at the highest range, we may call that as a free-flowing concrete.
Sir, one question, sir. Can we use the recycled aggregates for the self-compacting concrete?
There are studies which have used recycled aggregates for self-compacting concrete. But if you are aware regarding the recycled aggregate, so in recycled aggregate, there is a sufficient portion of mortar which is attached to the natural aggregates. Yes. Okay. And because of this, the performance of concrete means variation in the performance is very high. So we may use it, no issue as such. But if we are using recycled aggregate, our cementitious quantity may be increased and our flow requirement may also be increased. So we may have to use higher water as well as higher cementitious material for producing this. But it is possible.
Thank you, sir. Thank you so much.
Sir, regarding the setting time, sir, the setting time of this SEC is same as like a normal concrete, sir?
See, that depends on multiple parameters. First parameter is how much admixture you are using. So normal concrete will require lesser quantity of admixture, but self-compacting will require higher quantity of admixture. So because of higher quantity of admixture, you may have higher setting time for self-compacting concrete. Also, if we use higher quantity of fly ash, so fly ash is slow reacting material. So for 7 days, fly ash will not participate into strength gain of the concrete. Yes. So because of higher use of fly ash as well, the setting of self-compacting concrete will be higher. So we should be very careful in deciding the the setting time of self-compacting concrete. In the past, there have been cases where people have unfortunately removed the shuttering early in case of self-compacting concrete, and the structure was not structurally strengthened at that point, and complete concreting had to be removed. So a very good question. Though there is no clear-cut answer, we have to wait or we have to make testing at the laboratory to know the effect of admixture which is added and effect of the fly ash which is added. So you should be careful in removing the shuttering.
Thank you,
Sir, good evening.
Good evening.
Good evening, sir.
Good evening, sir.
Can marble dust be powder material?
Sir, excuse me, sir.
Hello.
Ma'am, I
One
could
by
not
one,
hear.
you can.
Yes, sir. Sir, myself, Prithviraj. Sir, I am also asking regarding that admixtures only. Which admixture is more adaptable, sir? Actually, we having a naphthalene sulfonated based admixture and polycarboxylic ether based admixture.
Generally, PC based is better, sir. Today it is having higher ability to of means water reduction. So for self compacting, we will use PC based. That is better.
Okay, sir. And one more question, sir. Regarding zoning of sand, normally concrete is using zone 2 and zone 3. Why can't we go for zone 4, which is you are mentioning that powder content, increasing the powder content will ability to increase the self-compacting nature. So is there any?
Yeah, please complete.
Yeah, is there any effect will be there by using zone 4 sand in that self-compacting?
No, very rightly you have pointed out. Very good question. See, zone 4 sand is possible to use in self-compacting concrete. A lot of people are actually. Excuse me. Gopinath.
Anyone?
Yeah. Thank you. Yeah. So when we are using a zone 4 sand, Gopinath. Yeah. When we are using a zone 4 sand, we are actually putting finer content into the self-compacting concrete. So up to a certain limit, as I said, we need some finer content, which should have maximum of 600 kg. Now, if we use zone 4 sand to increase that finer content, we can still use a zone 4 sand in self-compacting concrete. But as you are aware, generally the sand content is very high. Yes, हम जैसे normal concrete we add 600 to 700 kg of sand. In case of self-compacting concrete, we may add 800 or 900 kg of sand as well in concrete. Yes, so if we add such a high quantity of zone 4 sand, surface area will be huge and that may reduce the workability. So in short, I will say zone 4 sand can be used, but it may need higher quantity of super plasticizer.
Thank you, sir.
Good evening, sir.
Good evening.
Sir, I have a small doubt. Sir, what would be the maximum percentage or dosage of chemical admixtures in self-compacted concrete, sir? Is there any particular percentage?
See, generally, the manufacturers give their recommendation for maximum possible percentage for different chemical admixtures which they produce. As far as I know, a general thumb rule, I should say, we can consider that admixture should not be more than 1.5%. But again, this is something which we have to test in our laboratory. If I add it more than 1.5%, whether concrete is setting or it is not setting. If after, let us say, even 1.5% concrete is not setting for a long period, 1-2 दिन 3 दिन तक के set नहीं हो रहा है, I may have to reduce the quantity of admixture. And on the other side, let us say if I am using 2% of admixture and still concrete is setting in time, let us say थोड़ा सा delay करके 6-8 घंटे के delay के बाद it is getting set, I can use that. So that totally depends on how much retarding effect that admixture is giving on concrete. So if it is not retarding the reaction, you may use it up to 2%, 2.5% as well. If it is giving retarding action, then you have to restrict it to less than 1.5%.
Thank you, sir. Sir, one more small query, sir.
Sir, can I?
Hello, sir.
Yeah, please.
Sir, regarding mineral admixture in self-compacted concrete, I have small query, sir, in that way. Is there a mineral admixture like nano silica, sir?
Mm-hmm.
The nano silica surface area will become larger, sir. If we add nano silica with small percentage, the surface area which become larger, sir, as compared to other mineral admixtures like fly ash,
Yes,
GGBS.
that's right.
So it may affect any in self-compacted concrete, sir. That nano silica value.
Very good point. Nano silica is actually reducing the workability of self-compacting concrete. Yes. So from that point of view, nano silica is not very useful for self-compacting concrete. But what today is happening is we need not only self-compacting concrete, but we also need high strength concrete. So high strength concrete is only possible with nano silica. So we have to add nano silica into the concrete, but then our dosage of admixture is going to increase. So nano silica, because of its high surface area, is not desirable, or I should say it reduces the workability, but demand for high strength makes it compulsory material for self-compacting concrete. So we are using it.
Thank you, sir.
Hello. Sir,
Yeah.
can we use marble dust as a powder material?
Yes, ma'am. As I discussed during the presentation, there is a need of material less than 120 micron. So particle size जिसका 120 micron से कम है, ऐसे materials are useful for concreting. And marble dust, which is finer than 120 micron, it is useful in self-compacting concrete. But it may not be a pozzolanic material. It will just be acting as a fine material for increasing the viscosity of the concrete. What is its benefit is we don't have to pay or we don't have to use costly material like cement, but we can use a cheaper material like marble dust.
Okay, sir. Thank you.
Are there further questions? Yeah. It seems there are no further questions.
Question maybe. Yeah.
Sir, I have one more small question, sir.
Yeah.
Sir, nowadays quarries are depletion at an alarm rate, sir. Is there any?
Sorry, I could not understand.
Quarries, sir. Coarse
Query.
aggregate quarries
Okay, coarse aggregate queries. Yes.
Sir, nowadays it's a depletion. So is there any possibility to replace a fly ash based aggregate in self-compacted concrete? Partial replacement, sir.
Yes, it is possible. Today, as you rightly said, all means queries are limited. That is what is all about sustainability. Whatever is possible to have sustainable solution. So aggregates are produced out of fly ash. Steel slag, Meena madam is having very good work on steel slag aggregates. So multiple possibilities are there, and looking into the sustainability and scarcity of the natural aggregates, we have to shift to such materials. That is what is possible and that is what is sustainable.
Okay, sir. Thank you, sir.
Sir, I have one question, sir. Sir, I have visited one or two RMC plants. There only they do the slump test. They don't perform the L box J ring tests.
They were producing the self-compacting concrete?
Yes, yes, they have produced self-compacting concrete. What they do is to test the workability and segregation resistance. They do the slump flow test after every 60 minutes. So 60, 120. So zero slump. Zero time. Whenever the mixture is mixed. Then after 60 minutes, after 120 minutes, after 180 minutes. So is this a good practice, sir?
No. That is a wrong practice, and you have raised a very good question, I should say. But I can understand the reason why they are doing it, because it is the easiest test in self-compacting concrete. That is the flow. The most difficult test is V-funnel test. So what they do is they purposefully skip J-ring or L-box test and V-funnel test, because segregation means their concrete must be having segregation, and they themselves must be knowing that our concrete is not able to fulfill the V-funnel or L-box test. That is why they just check. That is means even
No,
I
but
have seen. Yeah.
After 60 and 120 and 180 minutes, we are getting slump flow in a decreasing order, but which are within the limits of the IS standards. So then cannot only some slump flow be used, sir?
No, ma'am. See, when I am talking about self-compacting concrete, there is filling ability, there is passing ability, and there is segregation resistance. So, complete self-compacting concrete can be, means we can call it as a self-compacting concrete if and only if all these tests are satisfied. And in our laboratory, we regularly perform mix design for self-compacting concrete, and we have to repeat or remix the concretes for the reason of V-funnel. Yes, so that is what I am saying. This is a tough test, very difficult to achieve in the laboratory, and that is why people conveniently ignore that. But to call it self-compacting, we must make all these tests. There is another test, that is sieve test. So sieve test is also simpler. So what a lot of people are doing is they are doing flow test, they are flowing J-ring test, and they are doing sieve test, but avoiding what is called as V-funnel test. So that is not right.
Okay, sir. Thank you, sir.
Sir, I have one more question, sir. As you discussed now regarding that in concrete ready mix plant, they are using time variation of slump flow test, that is flowability. Actually, we use that time variation in V-funnel only.
Yes.
Now, what my question is that above discussed participant tell that it is in an codal provision range itself only, that even after time delay test itself, the time reduction, the flow rate it is in limit only.
Yes.
But in our code, it gives 3 categories of slump flow. That is 550 to 650, and I think 660 to 750, and up to 850. It is SF3. I think so.
Correct.
But why can't we suggest that if it is in minimal range, it will be used for casting of slabs or unlikely reinforced section. It will be for lower slump ratios.
No, that is what is the philosophy. Means, see, achieving a self-compacting concrete is anyway costly. Now, if in that case, unnecessarily, let us say I have to cast a slab, and which is having a very low density of reinforcement, it is having a sufficient thickness, and in that case, having a flow of 850 is not needed. So just for economy purpose only, the IS code has suggested these three ranges, and this presentation will be shared with you, and even in 10262 you will find these ranges. So generally आपको क्या cast करना है उसके हिसाब से you have to decide the range which you want to use. So that is
Sorry,
there.
sir, I can't catch your language, sir. I can't able to follow your language, sir. I can't able to
इंग्लिश
understand.
सर हिंदी में बोले थे ना उसको इंग्लिश
Okay. So, see, IS code with the same philosophy, IS code has given this, I should say, ranges in flow 550 to 650, 650 to 750, and 750 to 850. The understanding is same that if there is, let us say, only a slab and which is having a very low density of reinforcement, why to have a 850 mm slump? On the other hand, when there is a beam column joint, as I have shown in my presentation, wherein the reinforcement density is very high because of the bond length, I may use a higher workability or higher flow self-compacting concrete. So that is the philosophy. It is from the saving point only. Because whenever you are having a high flow requirement, your cementitious quantity, your admixture, everything is increased.
Okay, sir. And one more last question, sir. Sorry to asking
No,
more
no,
questions.
I'm there for you. You can ask. It is good. I'm happy that you are asking the questions.
Okay, sir. Actually, we are having powder range of I think above 550 range to maintain the self-compacting nature. Why can't we reduce that powder content to normal concrete range, that is 450 up to? Within that, why can't we achieve that self-compacting? Is there any possible? Is there any way to do that?
Yes. Viscosity modifying admixture is for the same reason. With viscosity modifying admixture, I can produce the self-compacting concrete in the cementitious range of 400 to 450. So that is possible. When this viscosity modifying admixtures were not there, at that point we had gone up to this 600 kg of finer material or cementitious material. But now with viscosity modifying admixture, we can produce self-compacting concrete at 400 kg or similar cementitious material.
Okay, thank you, sir. Thank you, sir.
But as I said, you need to ask the chemical supplier for viscosity modifying admixture. So they may add that viscosity modifying admixture into superplasticizer, or they may give you as a separate material. So a lot of times people are not comfortable with such materials, and that is why they prefer the old school of thought, that is increase the cementitious material and have viscosity. So that is also possible.
Yes, sir. Recently, I have purchased a material branded name BASF. In that, inbuilt, they are giving a viscosity modifying agent with polycarbox based ethers.
That is good. That is good.
Okay.
The only reason means, for the commercial reason, they are adding two admixtures in one. Now, your requirement of superplasticizer and your requirement of viscosity modifying admixture may be different. Now, when you are having a single product with both the materials into it, you may be dosing higher dose of one for the sake of other. That is possible. So if they give or supply the superplasticizer separately and viscosity modifying admixture separately, that will be good for addition into the concrete. But for economic purpose, they are adding both the things into one sample.
Thank you, sir.
Yeah. Okay, ma'am. I think there are no further questions. So can we close the session?
Thank you very much, sir.
Thank you, ma'am. Thank you, everybody. Good night.
And thank you to participant. Okay, good night, sir. We will close.
I will close. Ma'am,
Any
कल
more
भी यही
question? हाँ सर.
कल भी यही लिंक चलता रहेगा क्या कि कल के लिए अलग लिंक रहेगी?
यही लिंक ट्राई करेंगे इसी को ही.
ओके, अदरवाइज मेरे साथ में शेयर कर दीजिएगा.
हाँ ठीक है सर. ठीक.
ओके मैम. थैंक यू.
Thank you, sir. Good night.
Good night.
And good night to everyone. And sorry for that interrupt. And tomorrow may not be happen. Maybe this type.
No, our director, let me say sorry on behalf of director. Our director is a very dynamic person and he is involved into many committees, and that is why he
And 2 FDP is going on, sir. In computer science department also 1 FDP is going on and started today only.
Okay.
And same time 6 p.m. only inauguration
Okay.
time. So that's why maybe little
That's
bit
why there
switch.
was some issue. Yes. Sure. So from tomorrow, we will try to see to it that every expert is available on exact time and there is no delay.
Okay, sir.
Okay. Thank you.
Yeah. Good night, sir.
Good night, ma'am.